Question: a conducting rod contains 8.5 times 10 power 28 electrons per meter cube. Calculate its resistivity at room temperature and also the mobility of the electron if the collision time for the electron scattering is 2 into 10 power minus 14 per second. So they are given the concentration of the electron as well as the collision free time. They are asking resistivity. If you want to the resistivity, we need to calculate the conductivity of the electron. That formula already we know. The conductivity sigma equal to the number of electron concentration of the electron time, the electronic charge square, the collision free time divided by mass of the electron. Once if you know the conductivity, then the resistivity is simple. The rho equal to 1 by sigma. Then the mobility also will be simple. This is the thing we are going to solve now. In this problem, the given data, first we need to write what are they are given. The given data are the number of electron, that should be equal to 8.5 in the rod. It's a 10 power 28 electrons per meter cube. Then the another quantity, the collision free time, the collision time they given, it's a 2 into 10 power minus 14 second. So these two quantities are given in the problem. What they are asking, the first one means the conductivity sigma. What is the conductivity of the, not actually it's a conductivity, they are asking resistivity. Once if you know the conductivity, then we can do simply using this formula, the sigma equal to 1 by rho. Then we can do the resistivity, because we can't directly calculate the resistivity using these two quantity, but we can do the conductivity, we can calculate the conductivity using these two quantity. So the conductivity formula, the first problem we are going to do conductivity. The next one we have to do the mobility of the electron, that we can do it next. So first the conductivity is equal to n times the electronic charge square times tau divided by the mass of the electron. This is the conductivity of the given material. So we know that n is equal to, it will be 8.5, it's already given in the rod, 10 power 28 times the electronic charge is equal to 1.602 into 10 power minus 19 times the tau. Tau is the relaxation time, it's a 2 into 10 power minus 14 second divided by the mass of the electron. It is constant, already we know the quantity, it's 9.1 into 10 power minus 31. This is the charge of the electron. So first what we want to do, if you collect the numbers first, then the 10 power next 8.5 into 1.602 into 2 divided by 9.1 times 10 power, here 28 plus 28 minus 19 minus 14. This is the powers in the numerator. Denominator is 10 power minus 39. If you are pushing it into the numerator, plus 31. So now what you have to do, actually it's a e square, that is the one thing we forgot. So you have to square this value. If you are squaring this value, it's a 10 power minus 19. So it would go minus 38. Here 1.602 whole square, because it's 1.602 whole square into 10 power minus 6 square for this one also you have to put. So if you are doing this simple problem, just first you have to do the interior parts. If you are doing that interior part, what you have to do, just you need to do the calculation first. If you are just subtracting this 38 plus 31, it will give minus 7. If you are subtracting this with 1, it's a minus 21. If you are subtracting with the 14, it will be plus 7. So 10 power 7 if you are doing this one. If you are calculating this quantity, it will give approximately 4.7. So this is the conductivity of the given material, 4.7 times 10 power 7. But we want to, their asking quantity is what is the resistivity of the given material. We know the resistivity is reciprocal of the conductivity. Just you got to substitute it in denominator, the conductivity value. So it will give 4.7 times 10 power 7. The resistivity should be equal to 2.09 times 10 power minus 8. It's a ohm meter. This is a resistivity of the given material. So this is the first problem we have done. Now what we got to do, we got to find the next one, the mobility of the electron in the material. So we know the mobility, the problem number B, the mobility of the electron, that should be equal to the conductivity divided by Ne. This we know the formula. If we are using the conductivity, we can derive this relation. We have the conductivity result, that would be equal to 4.7 into 10 power plus 7 divided by the number of numbers already we know, the number density, it would be equal to 8.5 times 10 power 28 into the electronic charge, it would be simple 1.60 into 10 power minus 19, that should be equal to nu. First collect the numbers, 4.7 divided by 8.5 into 1.602 times, if you are collecting the 10 power, it will give 10 power numerator plus 7, denominator minus 28. If you are pushing, it goes to the minus 28 numerator, plus 19. This minus 19, if you are pushing it to the numerator, it will be plus 19. So the mu should be equal to, suppose if you are simplify this one, in the numerator it's a 27, it's a 10 power minus 1. If you are doing this calculation, it will give a 0.035. So 0.035 it will give. This one it will give, it's a minus 1. So if you are writing at 3.5, that means if you are pushing this dot to after 3, it will give 10 power minus 3. We have the units is meter square, volt minus 1, the second minus 1. This is the mobility of the electron inside the material.